All right, good morning guys. We are going to try to do our first lesson via the internet. If you were in class earlier this week, Monday, Tuesday, Wednesday, you probably saw this stuff already, so feel free to follow through. If not, you can skip on to the next video if it's already been made. So what is it that we are focusing on now? We are looking at position time graphs. You should have this file on Teams. It would be under our notes section. It's linked directly to this page, or you can find it under files under Unit 2, the motion unit. You'll find it one way or another. If you can't find it, please send me an email and I'll be happy to walk you through it. All right, so what is a position time graph? Well, this is a position time graph. We simply have position on our vertical y-axis, and we have time on our horizontal x-axis. You guys have seen graphs before. We're not reinventing the wheel. This is what it looks like. What does it tell you? Well, a position time graph tells us where an object is at different times. What does that mean? Well, say we had some dots on this position time graph. This is time 0, 1 second after beginning, 2 seconds, 3 seconds, and so on. So say we had a dot at 1 second and 2 meters. That means 1 second after beginning, you know that a person or an object is at positive 2 meters. We'll talk about what positive and negative means in a moment. Say we had a dot under 4 seconds lining up with -3. That means at 4 seconds after beginning, they are at position -3. We could be in the same position at 6 seconds. Maybe we went back over and 8 seconds, we ended up at position 4. Being that position time graphs tell you where you are at certain times. At 1 second, you were at 2 meters. At 4 seconds, you were at -3, and so on. Positive positions means that the object is located on the positive side of the origin. An origin is just a set point that we call point 0. It's usually to the right of the origin for horizontal motion, so like walking backwards and forwards, and it's usually above the origin if we're talking about vertical motion. So maybe if you're skydiving or swimming. A negative position means the object is located on the negative side of the origin. So when we're talking about positives and negatives, we are looking at our position axis. This is your positive side of the position time graph. This is your negative side of the position time graph. So over here, you're to the right or above the origin. Here, you are to the left or you're below the origin. This would be above the origin, below the origin, below the origin, above the origin. Or if we're doing right-left, to the right, to the left, to the left, to the right. Okay, let's keep on going down here. The steepness of a line on a position time graph indicates the speed of the object. Basically, a steep line means that you have a fast-moving object. A shallow line, so less steep, means you have a slow-moving object. A horizontal is a stopped object. So what do we mean by steep? It could be going up and to the right quickly, or it might be going down and to the right quickly. So these are, steep. We can go up and to the right slowly or down and to the right slowly. These are shallow. That means you are going slow. Horizontal is just a flat line. That means that you are stopped. Position is not changing over time, so you are not moving. Whether a line rises to the right or falls to the right determines which direction the object is traveling. So if you are rising to the right, it shows you are moving in the positive direction. So that's that guy there. Or this one. A line that is falling to the right, so starting high, going down, shows that an object is moving in the negative direction. So you're going towards the left, or you are going down. That's a line like this, or a line like this. So if we reiterate on here and say we connected these dots, if we started at the origin, we know that there's a point at 0 seconds, 0 meters. You can see in 1 second, they made it up to 2 meters. 3 seconds later, they are 3 meters to the left of the origin. A horizontal line means they are stopped. And then moving to the right again, they cross the origin and head in the positive direction. Now, a lot of these lines aren't crazy different in steepness, but you can see this line is a little bit less steep compared to this line, which means they are moving quicker during this point. Looking at a position time graph, often we have to look at a number line. So these number lines show where an object is located. So position tells you where an object is located relative to some origin. That's at your 0 mark. Physicists use a number line as a frame of reference so they can easily indicate an object's position simply by giving a number. So if we're taking at this number line, the entrance is at the origin here, that's our zoo entrance, and also shows where a few of the animals are. So in our picture, it is the zoo that's located at the origin. The bear, this guy over here on skis, his position is positive 10, which means that he is 10 meters to the right of the origin. The rhino's position, this guy mean mugging us, he's at -4, which means he is 4 meters to the left of the origin. 1, 2, 3, 4 to the left. And the monkey's position over here, he is at +5, which means he is 5 meters to the right of the origin. Origin is here, going in the right direction. 1, 2, 3, 4, 5. Fantastic. Back side of that page. So we're looking at that bear again, but he's doing a little bit of skiing and he's moving around. It says here we watch him and record what he does, often use the X symbol as for our position, because the horizontal, our x-axis in math, gives us our number line here. So our bear, he starts at x equals 5 meters. So if he's starting at 5 meters, that's where time is going to be equal to 0. So at time equals 0, he is at +5, which is telling us right here. He then walks to x equals -3 meters, which is over here, in a time of 4 seconds. So since it took him 4 seconds to get over here, the time he gets to -3 is 4 seconds. It lingers there for 2 seconds, which means he doesn't move for 2 seconds. So time from 4 to 6 seconds, they are at -3 meters. And then finally they run, so they're moving more quickly, to +11 in 2 seconds. So we move all the way to position +11. Since it's 2 seconds after 6 seconds, we have time equals 8 seconds. There's lots of different ways of looking at this situation. Another way that a lot of people are comfortable with is a data table. So we have a data table going vertically or a data table going horizontally, which tells us all the exact same information. At what time was and what position were they at? So at time 0, as we see here, their position was +5, as we see here. At time 4, they were at -3, which we show on the number line and we show on the vertical. And It gives all of our times, all of our positions. What we're looking at with our position time graphs is the same motion indicated here. We've got our position, both positive and negatives. We've got our time moving forward. We show our different data points with dots. So 0 seconds, 5 meters is shown right there. At 4 seconds, they were at -3. 4 seconds, -3. At 6 seconds, they were still at -3. 6 seconds, still at -3. At 8 seconds, they were at 11 meters, positive 11. So 2 seconds later, we scroll up and we find 11 meters. So at those points, we know where they are. We're going to assume they're moving at a constant speed, so we're going to connect with a nice straight line. And we can actually figure some things out just by what this line looks like. This is a shallow line, remember that steepness, moving down and to the right, which means they're moving slowly to the left. This horizontal portion of the line tells us that they were stopped. Time kept going forward, as it tends to do, but their position didn't change. So they were always at -3 meters for those full 2 seconds. And then finally, we have a steep line going up to the right, which means they were moving in the right direction in a quick motion. We can do some neat things with this. We can find out where they were at different portions of time. So for example, if we wanted to figure out where were they at 1 second, we would find 1 second, we would follow that up on the graph, and then bring that horizontally over to our position axis. And we could estimate that at 1 second, that bear was likely at +3 meters. There we go. That's our quick intro. If you have any questions, please post on the message board or send some emails if you're feeling shy, or messages, whatever you need to do. In a little while, we will be posting the answers to our question booklet in kind of a walkthrough style. So this is the next thing you guys are going to be looking at. Please use your notes to answer some of these questions. It will really help you along. And stay tuned for the walkthrough. All right, thanks guys.